Alrighty, good morning everybody, or good afternoon. I'm going to be doing a lesson. My name is Mr. Geyser on chemical reaction rates and temperature. Alright, this lesson is going to be based on the standards on the bottom of your screen here. High school PS1, Physical Science 1-5, collision theory and rates of reaction. Now I know we only have a short time together, so I'm going to try to keep this pretty brief. I have a few slides that I want to go over just to give you an outline of what a typical lesson would look like and kind of cut out some of the bits because obviously we don't have a class behind me. So I'm going to kind of give you an overall view of what a typical lesson would look like for me and what are the things that I would key in on, maybe some questions that I would ask, and just kind of the general overview of things. I apologize if I'm going out of the frame. I just have to switch over the slide. I'll be able to do it from here. So let's try this first. That should work great. Awesome. So when the students walk into class, they would always be greeted with a slide similar to this one. All right, I always try to keep a general overview of what they're going to be doing that day. That would be indicated by the objective, of course, as well as a do not question, just so students are already starting to think about the topics as they are walking into the room. So for our lesson about chemical rates and reaction theory, all right, I would be going with the do not question. List 3 ways you think the rate of a chemical reaction can be changed. Now, this is one of the earliest standards that we have in a chemistry unit. So at this point, students would probably be familiar with what a chemical reaction is, what are some of the indicators that tell us a chemical reaction taking place, as well as like what a molecule is and how different atoms are related to each other and how different states of matter react as well, okay? So today's objective, I would probably read on the board as, you know, the students are starting that do not question. So students are going to be able to, by the end of this lesson, describe how temperature changes the rate of reaction using collision theory. Now, at this point, I probably wouldn't explain what collision theory is. It's going to be our first introduction to that idea. But as the lesson goes on, I would start to talk about collision theory more and revisit it towards the end of the lesson. So students are seeing it right from the beginning, and we'll expand upon that idea as the students go through the lesson and the lab activity. Now, students would take a few minutes. It would probably take somewhere around 5 minutes. I would ask them to do sort of like a think, pair, share. So talk to the person next to you, around you, and think of 3 ways that the rate of a chemical reaction can be changed. Okay, so I'm trying not to do anything super scientific at this point, just starting to get the students involved and start to think about their learning. So then again, that would take about 5 minutes. We're skipping ahead, okay? After a few minutes, I would introduce the students to the subject or the phenomenon of today's lesson. In this case, it's going to be the reaction between vinegar and sodium bicarbonate, a very classic example of a chemical reaction, and one that students are probably familiar with if they have ever experimented using some household objects. So something that's familiar to them, but using it in a class concept, using this reaction as sort of like our subject. So I would show them this quick video, and it's only about, let me go to the volume. It's only about a minute long. I'm only going to play the first 45 seconds. Ideally, so this video works great as sort of like an introduction, but ideally I would have the equipment in front of me, and I would actually do this as a demonstration where I would actually have vinegar and sodium bicarbonate, and I would actually mix them together to show my students the reaction. But I would play a video just like this. And I love to use videos when I'm teaching because, one, it keeps students engaged, also to kind of differentiate the lesson a little bit, showing them kind of, a video as well as doing a hands-on activity. It kind of creates a environment where we can create, cater the lesson to different types of learners. So again, the reaction is kind of going on. Students are looking, oh, look at how it fizzes up. And while the video is kind of playing, and I'll pause it here. While the video is playing, I would have students, I would give them prompts, right? Questions I would either write on the board or maybe address to the class just verbally, what they should be thinking about as they are kind of looking at this lesson. So I would look at them and say, how do we know that a chemical reaction is taking place? Okay? What type of reaction is taking place? How do we know that a chemical reaction is taking place in the first place, right? We have to kind of start at the baseline there. And I would have students kind of observe the video, and I would ask them after the video is over, what did you observe? What is going on? Okay, and again, how are we knowing that a chemical reaction is taking place in the first place? Okay. So again, I would physically, if time allowed, have maybe a desk or 2 up at the front, and I would actually do this reaction because I feel like physically seeing a reaction is a little bit more better for the students than just the video. But again, it all depends on how much time this lesson would take. But for right now, that's the video, the little phenomenon that we are talking about. And again, they are going to be actually doing that physically as a class as well. So they're going to be getting their hands dirty, just like I love science to be. And that's going to be through a lab investigation. I love to do labs whenever I can. Labs are kind of the backbone of science. It's so much different than any other class that you're going to teach in the school. Getting kids actually involved in the science and using all these different, scientific tools and different chemicals, mixing them together. Physically seeing something happen is the coolest part of science, and definitely something I try to incorporate into all my lessons. So for this lesson, I would plan an investigation all about temperature and reaction rate. Again, going back to the theme, the goal that I have for my students at the beginning of the lesson, how does reaction rate change? How can we make the reaction speed up or slow down, okay? And they're going to be doing that using this lab investigation. Now, of course, I would have probably a handout. I would pass it to my students as I'm explaining, and I would also have the material somewhere off to the side that I can actually show them what each material is. But for this lab setup, it's quite simple. Again, it's something that could be accomplished at home for the students. I always like to keep them as simple as I can. So we have vinegar, of course, baking soda. I would do about a cup for each group, okay? I know the class would be about 24 students, so I would try to have students in groups of about 3 to 4. I think that would work out perfect. I would have 3 beakers of water, one with cold water, one with room temperature water, and one with hot water. Those would be our 3 independent variables for this experiment, and we would keep the reaction exactly the same. So again, about a cup of vinegar and a cup of baking soda just to keep everything consistent, and then we're only changing the temperature of the water. Students would also have a stopwatch, so the idea is that they would put the vinegar and the baking soda together, just like they showed in the video, and they would have that reaction take place where it bubbles up, and then they would record how long it takes for that reaction to stop for all 3 of the different trials. Now, students would also be recording not only the time, but also the temperature of the reaction as well. So they're going to be writing that down. Again, I would probably have some sort of data table printed out on a lab worksheet, and students will be using that throughout the lesson. Now, for the procedure, I would keep it pretty brief. Again, measure the reaction time for each temperature, that again being the cold water, the room temperature water, and the hot water. Record your results in some sort of data table, and then complete 3 trials for accuracy. So this would be the bulk of my lesson. This would take anywhere between 15-20 minutes of the lesson, of our 40-minute periods like we have here. And this, again, getting students involved, working with groups, having them collaborate with their classmates, creating that positive classroom atmosphere. That's what I'm all about. Again, science is so unique in this way, where we're actually having students getting involved with one another, getting their hands dirty, and it's so unique. And I want to have that reaction and that process with my students as much as I possibly can. In this lab investigation, even though it might seem simple, it's a great way for students to see a nice quick reaction and then ask some questions afterward. Okay? So again, this would be the bulk of my lesson, about 15-20 minutes. After they're done and they do all their different trials, they're jotting down the time that it took for each reaction to take place. They're getting their measurements, their temperature readings off the thermometer. Then I would have the students come back to the desk and we would have a group discussion about what they would see. So we would have a brief discussion. We would go over the fact that the warmer temperature reaction should have been the quickest, right? And we would ask questions. So why is this taking place? Why do you think the warmer temperature is actually the one that happened the fastest, right? We would also have students probably come up with a hypothesis, and we would say, does this meet your hypothesis? And kind of have that discussion as well. And that would go into the actual explanation of what they saw. So again, at this point, I have not mentioned anything, super scientific, not related to chemistry, and it would kind of tie it all together by talking and introducing this idea of collision theory. Now, of course, collision theory is going to be the idea that as the particles are moving faster, they are going to interact with each other, they're going to bump off each other, right? And as we have more of these collisions, that's going to increase the rate of our reaction. As I was going over, and again, I would probably have a few more slides than just this one, but I would hit on these couple key concepts as I'm going. So again, particles must collide to react. So it's important for students to realize that they are individual molecules, individual particles that are actually colliding and reacting with one another. And again, as you are speeding up those reactions, they are colliding more frequently, and that's going to increase the rate of our reaction. Again, higher temperature equals faster particle movement. I would probably introduce at some point the idea of kinetic energy. That's the idea that the faster the particles are moving, the more energy that they have, the more collisions we're going to have, and again, that increased reaction rate as a result. So again, that faster movement leads to more frequent collisions, more energetic collisions as a result of our increased kinetic energy, and then a higher success rate of reactions. I would emphasize to students that a chemical reaction is nothing more than a random process of molecules bumping into one another. So even though it appears very quick, right, and it is happening very quick, okay, it is all the result of those molecules and those, increasing kinetic energy and then bumping off and colliding with one another. And again, this would take about maybe 10 minutes to go over. I try not to do too much lecturing and standing up in front of the board. I'd rather students spend the bulk of the class at the lab tables, using the different scientific tools and getting their hands dirty, working as scientists. That's kind of what the whole new NGSS standards and everything is supposed to be geared towards. So again, this is now introducing collision theory. This would be about 30 minutes into the class, so we're getting towards our time here. Okay, after the students now know about collision theory, I would start to ask them some analysis questions. Now, the first thing I would do before we get to those questions is have the students create a very simple line graph. It is always a good idea to practice the students' graphing. It's something that my students constantly have problems with. So we're going to practice our graphing skills by creating a line graph, very simple. X-axis is going to be the temperature, y-axis is going to be their reaction time, so how long did it take the reaction to complete, and then we're going to plot all three trials. And again, students should see as temperature increases, so does reaction time. And once they're able to get that graph created and they're able to put their data points on an actual graph, they're going to analyze that graph and they are going to figure out what is actually going on. So these would be my two analysis questions. How did changing the temperature affect the rate of reaction? And using collision theory in your answer, so I'm bringing back that key point from the objective, how do we actually take collision theory and use it to analyze our graphs? So using collision theory in your answer specifically, why does changing the temperature affect the rate of reaction in this way? And I think those two analysis questions do a great job as serving as sort of a formative assessment of my lesson. So after this, I would take the lab packet, or maybe it's just a simple piece of paper, and I would collect this from the students at the end of the lesson. And this would serve as, again, a formative assessment for my class, and also using it to instruct future lessons. So maybe students are still a little confused, maybe they're using collision theory in the wrong way, and that would prompt me to maybe bring back collision theory in the future and reflect on it and maybe see where students are going wrong. Now, of course, collision theory and doesn't rely on just temperature. It also relies on the amount of reactants present. That would probably be something that I would use in a future lesson. So maybe next lesson I would come and say, all right, guys, remember the collision theory from the day before? What is it? And maybe what is another way that you think the molecules can more frequently bump into each other? And that would prompt us to maybe have another lesson, again, maybe the next day, day after, about what other ways can we use collision theory? And again, bringing it back to temperature and the reactants as well. How much reactants are present. One more slide. I don't. So that would be the end of my lesson. Okay. Again, I just want to do a quick recap while we still have a few minutes left of this video. Again, I would start with having the students come in, looking at the do now, talking to one another. We're always having a nice positive classroom environment where students are encouraged to collaborate. I would have them first discuss what they know previously, get out any sort of misconceptions about what they know. They would eventually move into the lab tables and work on that lab activity, and that would be the bulk of my lesson. And then afterwards, I would bring in the more scientific terms of collision theory and rate of reaction. And then finally, I would have students analyze what they learned and put it graphically. So we're seeing the students answer questions, but also put it into a graph. So we're seeing students use